Hi, back for another session of Tea Time, which is basically T theory is time theory, and it is a prediction as to the physical structure of the universe. The prediction is that instead of a multiverse, this is also kind of a multiverse, but it is I would describe it as a dualiverse. In other words, it's based upon the concept of a duality in time. So that's what T theory stands for. This would be where we talk about the singularity. This would be a singularity that preceded the Big Bang, and the singularity, as it broke symmetry, that symmetry was broken at the Planck time, or the Planck length, and that yielded space-time. So there's two concepts of time. There's space-time, which we exist on the membrane of space-time, and then there's the singularity time, in which precedes space-time. And the idea is that partly why it's called T-time is that it's the concept of timeless energy access. And the first concept of timeless energy access is the Planck sphere. This is a term that has not been described before, so I'm bringing this term into existence. At least I'm not aware that anybody has done this before, but it's based upon the Planck time and the concept of the singularity that preceded the Big Bang in time, which came before space-time. Also, the relationship of mathematics to space-time and to mind, and this whole process is basically, this would be the cause before the effect, which would be broken symmetry, and this would be supersymmetry. So one of the terms described here is that supersymmetry is a state of the singularity, which a singularity has supersymmetry, and this supersymmetry then broke symmetry and gave us space-time. One of the key questions that T theory asks is basically, what is the single thing in the universe? So the idea is that if we were going to boil down everything to one thing, what would that entity be? That entity in T theory is energy itself. So energy is the single thing. I'm just going to abbreviate NRG. So energy is the single thing in the universe, and everything should be related back to that single thing. So starting off, I'm going to discuss what the Planck sphere is. Okay, so if we take the singularity as being the single point where it has infinite density and is not space, it does not have any space-time characteristics. So it's a point of infinite density with no space-time. In T theory, the density is equal to mass, and of course mass is equal to energy. So the singularity is an energy state of the universe. However, different than space-time, in which energy is not created nor destroyed, like in thermodynamics. The singularity is a point where energy actually is created, and in T theory we'll talk about how it's annihilated, how energy, in other words, how you can take energy and add energy together and create nothing. So you'll actually have the energy of nothing. Energy of nothing we'll be talking about. So starting off though with the Planck sphere, we start out with the singularity, would be this point, and then we broke symmetry, and that symmetry would have been, say, here. So we have the radius being basically Planck time and Planck length. So Planck length is 10 to the minus 33 centimeters. So give a reference to both length and time. So this would be the radius, and of course the radius of a sphere would be kind of like this, in which if we go back from where we are at the moment of now and we go backwards in time 13, say 0.7 billion years, or 13.8 billion years, and we come back up, right up to what's called the Planck length or the Planck time. So, and this is where theoretical physicists say that mathematics works all the way up to here, but at this point it breaks down and mathematics no longer works at this point. And this is the Planck, both Planck time and Planck radius. So, although it hypothesizes or predicts that if we went back to zero time, that's what we're trying to get mathematics to go to, zero time. However, if space-time breaks down at 10 to the minus 33 centimeters or 10 to the minus 45th of a second, this represents the singularity before the Big Bang, and then it broke symmetry. This is the so Planck time and Planck length are theoretically outside of space-time, in the sense that if our resolution of space-time just comes up to here, then inside of here, this is a plate where space-time breaks down, but we're still Planck length, and Planck time is talking about this time inside, which theoretically doesn't have a mathematical agreement with regular space-time mathematics. So thinking now, here's the sphere in which the singularity here pre-existed before the Big Bang. The Big Bang then would have came out, and then basically at this moment here would be the Planck sphere, and this is where the bang would start. So this is where initiation of the Big Bang. So we actually have space-time, but then we also have what's called a singularity time in T-theory, and this is singularity time, as we talk about here. So there's a singularity in time, and that it broke symmetry, and that's the Planck time to where we broke symmetry. So in some regards, this is the very first Planck sphere in the universe. And since this moment, and since 30.7 billion years, we probably have an infinite number of Planck spheres. And the concept of infinity here is also a little different in T-theory than with typical mathematics. You know, a lot of mathematics talks about infinity. Infinity is related to numbers in mathematical terms. However, in T-theory, infinity is related to energy, because mathematics doesn't create energy, but energy can create mathematics. So what is the single thing in the universe? We talked about that, is energy. Everything's got to relate back to energy. And so that's where we're talking about now, is that the singularity would be an infinite density or infinite mass of energy, and that energy is different. Talk about infinity. In T-theory, infinity is an acceleration. So if we were talking about F equals ma in the concept of a force, if we're talking about unifying all the forces of nature. Now remember, if we take, if we talk about F equals ma, we have a force, but that's equal to mass, and that mass is accelerating. So that would be the unifying force causing for all mathematics. Now remember that if we take 2 times the Planck length, so say we're out here, this again is part of the Planck sphere, and so basically this is the Planck sphere in which at this moment in time here somewhere, this is where the strong nuclear force would came in. Also, you know, the electromagnetic forces would come into existence and things like that within this space-time, because the second, you know, this is just 2 times 10 to the 33 centimeters, or 2 times 10 to the minus 45th of a second. And so a second hasn't even occurred yet the sphere and the sphere would consist of basically quantum foam, as it's known. It's basically the point where the space-time is actually breaking down, all foamy, I guess, if you want to consider it, where there's no forward or back, everything's kind of mixture. And outside of the Planck this quantum phone is, of course, going to be in the concept of string theory, is where the strings of string theory are going to exist. So basically, we're going to have closed looped and open loop strings. Again, a duality there, same thing as T theory is predicting, a fundamental duality, just as general relativity and quantum mechanics have like a fundamental mathematical duality to them. Part of that reason is because quantum mechanics actually exists with waves, and waves would be at the beginning of the space-time, so we'd have waves coming into existence, you know, at this point. However, prior to this would be infinite energy of acceleration, where gravity, the force of gravity, would be here. So actually, the reason why we have two sets of partly mathematics is because the source of energy and the source of dark energy and the source of the forces is kind of at the singularity, versus space-time would exist after breaking symmetry. So say we have the very first Planck sphere, and now we have an infinite number of Planck spheres, so that at the center of space, is this Planck sphere, in which all matter in the universe will have a relationship to this, you know, so that the center of mass will be relative to the matter that we have. So we have an electron, say, sitting out in space. That electron is going to have going in towards the middle, so the electron will be way out there, and then at some point we approach the Planck sphere, where the sphere is actually, again, where a lot of the forces coming into existence, and then inside of the sphere is where, again, Planck, the quantum foam, and inside of that is our Planck time and our Planck length. So even though these are concepts theoretical physicists use all the time, Planck time and Planck length are actually outside of the universe, in the sense that they're before the universe. So the idea is that all matter and everything has a reference point to the singularity, and all the singularity still exists in our current time and is preceding our space-time, as we're creating more and more, basically, Planck spheres by creating more space. So this also answers, you know, Einstein's sort of concept of infinitely curved space would be this Planck sphere, would be the infinitely curved space in which space-time is curved here. It also could explain wormholes reaching other parts of the universe, because if we can access the Planck sphere until here, theoretically, once we come to the singularity, this singularity is besides being the first singularity, T-theory predicts that the singularity inside of all black holes is also the same singularity. It is also the same singularity which is the center of space-time itself. And this singularity precedes our space-time, so that's why we actually have a future in time, why there's a future, and we live in the moment of now because we're broken by this symmetry. And this symmetry is basically the timeless energy access. So the break in symmetry is the access to this energy that we're talking about, that is being accelerated and being created inside the singularity. Now, the concept of the energy of nothing is basically where it's not absolute nothing, but where we were talking about waves. Waves are energy, right? So, but if we take energy, say we take a bunch of waves that have like lots of, remember that in string theory, part of the ideas of particles are that these particles vibrate, okay, and their vibration will yield the different, the strings will yield different particles in nature, such as an electron and some of the other, you know, particles of matter, and different resonances give you different particles. What theoretical physicists don't seem to mention is that, like a string that generates a note, say a guitar, there has to be a tension on the string, and in T-theory that tension would actually be quantum gravity, the tension of the string, because floppy strings don't give you any notes. So there has to be a tension. There's a tension on the string which is provided by the acceleration occurring within the singularity. This tension then would be causing the strings to vibrate, which would then theoretically give you the particles. That's supposing that the string theory actually is a viable mathematical concept. The other thing to bring in is that now I talked about adding, so we have waves of energy. Now if we took the exact opposite phase of that energy and added them together, so that you actually have 2 times that amount of energy in waveform. So here's one that has lots of energy, say this is a simple wave, but say this was a complex wave where it had all the particles of nature, and then you had the inverse phase of that particles of nature. You could actually be adding these energies together and create 0 energy. So this would be the energy of nothing, where you add energy of waves together. In the process of combining them, it gives you 0 energy. If we took this and added them, looked on an oscilloscope, you would say 0 energy, but in reality, the truth of it is that there's energy that was added together, so this is the energy of nothing. So if you have a system which is creating energy, the energy in nothing, it could actually be energy in balance. So we always talk about supersymmetry. If this energy is supersymmetric energy combined together, then that energy will appear as nothing, yet there is energy there. Where when we break symmetry, that's, again, when we break the symmetry, maybe the time difference between the 2 waves doesn't actually match up equally, and such you begin to have physicality based upon that. And that can be shown by just combining waveforms together that are, and say one waveform and another waveform, combining together and then changing the time of one, say delaying this one a little bit, or breaking the symmetry of that, delaying that will actually cause for physicality of sound, where otherwise you add those 2 waveforms together, you'll actually appear, it'll be no sound. So the idea is that there's actually energy that precedes our universe. The physical structure of our universe is really based upon the Planck sphere. And when we talk about the concept of mathematics and the unreasonable effectiveness of mathematics, is the fact that it's based upon a supersymmetry, and that would be the supersymmetry of the singularity. However, because space-time doesn't exist, and this is space-time is actually where the point where the mathematics of space-time actually is stable, so that 2 plus 2 equals 4, right? You know, outside of the Planck length and Planck time, 2 plus 2 is going to equal 4. However, and this 2 plus 2 equals 4, it was equal way back to the moment after we broke symmetry at this time scale and distance scale to where we are today at 13.7 billion or 13.8 billion years after the breaking of symmetry. So that after so we have mathematics working all the way up. Now, when you ask theoretical physicists about, you know, mathematics or about the nature of reality, you know, scientifically, a theory is based upon whether you can mathematically describe it. So mathematics is the fundamental concept of, you know, having, for theoretical physics, whether you can measure it. Okay, so you'd actually be able to say that something was 2 plus 2 equal 4. You actually measured it, that was true, or whether you observed it, you know, from different individuals. However, there's a duality in that assumption, because you can't calculate anything, you can't measure anything, and you can't observe anything unless there's mind. Our mind is a fundamental constituent of mathematics and measurement and observation, such that they exist together. The next question actually that is a key question. Besides what is the single thing in the universe, it is whether is it possible for energy to become aware of itself. And think about that for a moment. Is it possible for energy to become aware of itself? That being, for example, us as human beings are proof and examples of energy becoming aware of ourselves. So obviously we are proof that energy can become aware of itself. But when we're talking about cause and effect for the universe, I guess the next question is if we are an effect of the breaking of symmetry, human beings, and our mind is something that emerged as an effect of this process, and if energy can become aware of itself, is it possible that we inherited this awareness from another point in time? And theoretically, it would be to the singularity if that were to exist. So the idea being could the singularity, if the singularity was pure energy and accelerating, could that energy become aware of itself enough to want to break symmetry? And of course, one of the things about the arrow time and breaking symmetry is that time basically goes in one direction, the arrow time as they talk about. But if you think about energy, if you create energy, you can only go one direction. So what is time? Time is equal to energy. The difference being is that in the singularity, energy is continually being created and not destroyed, in the sense that it's being annihilated, but it's still there. So we get the energy for the dark energy because we broke symmetry, and that's basically space-time, the cosmological constant, which basically says there's a certain amount of energy in space-time. It also kind of, when we talk about, physics has this one number, 10, that it predicts to the 120. When they analyze space-time and the energy they say there's 10 to the power of 120, and they go, that's absurd. There can't be that much energy in empty space. Yet when they measure, of course, what they measure space-time as being is being 1 over that. Space-time is 1 over 10 to the 120, so that this is equal, so that space-time has a constant value, which is about 2 protons per cubic meter. And since at the beginning of breaking symmetry in the universe, if we didn't have, obviously there's a relationship to energy that theoretically, if we have an infinite space-time now, then energy is actually increasing, and that violates the first law of thermodynamics, which is basically energy cannot be created nor destroyed, only transformed. However, obviously, if we have more space-time, it's infinite. Where is that energy coming from? So the energy is coming from, in T-theory, the singularity. And the singularity is still existing and precedes our current space-time, and it is continually, it's timeless energy access. So that we're continually accessing this energy, but we broke symmetry by putting randomness into symmetry. And that randomness helped drive the relationship so that the forces, which would be so strong, which would cause supersymmetry never to be broken, the way of breaking symmetry is by adding randomness into the symmetry. And so thus, they say this was the point of the highest order of the universe in which entropy has increased continually throughout the rest of time, which would make sense if you had to continually break the symmetry, and the Planck time has always maintained consistency, both the Planck time and Planck length, which basically says this distance has stayed stable. And the question is that even though you may have broken that symmetry through randomness, it wasn't absolute randomness, because this length has stayed stable. This is one of the constants, the Planck time, the Planck length. So is that breaking of symmetry, was that intended, or was that fully random. And that then becomes part of T-theory. T-theory really stands for total time theory, in which it predicts what's a dualiverse as a functional structure, such that we have the singularity in the middle. We have this Planck sphere that exists, and that singularity precedes the Planck sphere. There's an infinite number of Planck spheres at the center. This would be infinite curved space. Also, at the same time, we have access to this energy because the singularity is continually creating energy, accelerating energy, and that's what we observe as the universe, as space-time is accelerating, and that's where, you know, we see the observation of the microwave background. That's what the prediction of theoretical physics is, that the whole energy is accelerating of space-time is accelerating. So the concept here is that this energy is actually when theoretical physicists look at this space-time as having this large number of energy, which is one of the biggest errors they say they have, which actually is in T-theory is not an error. They just come up against they don't have the concept of the physical structure, which is again a dualiverse model where there's a duality in time, and the duality of time is the creation of pure energy and the acceleration of that energy, breaking of symmetry through the input of randomness. That randomness wasn't an absolute randomness, but a degree of randomness. So the randomness itself is energy in T-theory. And the fact is that if we consider the structure, it may also put in the concept, when I ask the question, is it possible for energy to become aware of itself, would be, is it possible that this whole process was intended? Now, something that is intended would mean that you would have set rules and set things in place before you start something. So the idea is that if things were broken randomly, you would expect 2 + 2 not to be equal 4 immediately. It would have to be an evolution if things came together. The forces would not be immediate. The strong nuclear force, electromagnetic, would not have been immediate. They would have evolved slowly in time. You know, and the effect of gravity on everything would not have been there before the breaking of symmetry. So if these things occur where the unified force, the unified structure of the universe, this to me totally makes sense as far as a physical structure to what we observe, because what we observe is spherical objects out there. We observe planets, stars, galaxies that have a kind of a circle appearance, black holes. Everything's related down to a sphere, and centrally here in T-theory, it's this particular Planck sphere that is the concept where everything comes down to, in which the singularity, again, precedes our space-time. The reason why we have a future, a now, which would be the continual, in other words, these forces are continually being formed. They're not like it's not like a true particle in the sense it's a piece there that lasts for all time. A force is continually being created. A force needs a mass and an acceleration. Well, that mass and acceleration is provided by the singularity. In other words, the quarks that are inside of the proton, the 3 quarks themselves are almost massless, and yet what gives the proton its actual mass is the confinement, the prevention, the pulling together and preventing those quarks from leaving. That is providing the mass. In this case, the singularity would be pulling because for the pull of the quarks, and that's where the energy is being caused from in this concept. So T-theory, supersymmetry, we broke symmetry to end up with space-time. It's 2 times. One's a singularity time that has no space-time, and then we have space-time and matter and on the broken symmetric side. So the physical structure of the universe is that it's a sphere based upon the Planck sphere. And just one last comment in here is that theoretical physicists has proudly admitted that they're not interested in the why questions, why things may have happened. They're only interested in the how. And in that aspect, they can't actually give us a total theory of everything. They can give us a mathematical formula that might describe how energy behaves in the universe, but they won't be able to tell us why that exists. Like, for example, in gravity with Newton, we talk, now if this were an apple, and I drop the apple and I ask you what is gravity, you'd say, it's the fall of the pen, that's gravity. Well, actually, that's not what causes the pen to fall. Gravity, as Newton described it, would be describing how that actually fell. So the falling is the effect of gravity. It's not the cause of gravity. The cause of gravity would be this acceleration force that's pulling on the pen. Likewise, if we have time itself, if we see the tick of the clock, when we say, what is time? We say, oh, a clock is time. Well, the click of the clock is the effect of time moving. So the clock is not the time, just as the falling of the apple is not gravity. It is the effect of time, the effect of gravity, and ironically, the singularity is the place where both gravity and time are caused from. So this is the cause of time. The cause of gravity would be in the singularity. The breaking of symmetry basically gives us the difference between physicality and energy, and then the singularity is energy and non-physicality by being a supersymmetric and balanced energy. I'd like to bring up one other aspect. There's this concept with philosophers and so forth, that of the concept called panpsychism, or the idea that consciousness could be part of the universe. And I wouldn't call it consciousness. I think something's more primitive than consciousness. Consciousness is, to me, the point of where you can assimilate and put things together, versus the concept of intention. In the next session, or one of the future sessions, I'm going to talk about the relationship of energy to intention, and the fact, if you look at everything physical in the universe, whether we made it, and I would use us as an example. All human beings are, I asked you, what is the single thing in the universe? I told you it's energy. And I asked you, is it possible for energy to become aware of itself? And I gave you an example, human beings, as energy became aware of ourselves. And if we look all around us, whether it's this blackboard, whether it's me writing this out, or a mathematician, theoretical mathematician writing out, derivatives and all those other things, they don't get to write down anything without intending it first. So that everything physical, if we look at our own human beings, everything that we look around that exists, that is physical, almost everything that we are involved in, we intended first, and then we provided a design for that. But before the design came the intention. And that's kind of where Descartes, when he mentioned, I think, therefore I am, the process of the thought actually came with an idea. So if you have a thought, whether that thought may, for Newton's things, may have been calculus, that thought then became physicality as he described calculus, because his intention was to describe the motion of planets. But unless you have that intention, you don't get to, that's calculus that can describe that, and then of course he formed calculus. So it's the intention that actually is preceding, and intention in T-theory will be derived from here, which is off the space-time membrane. So that's why when we stop at a red light, we stop first, because not because it's red or it's breaking the law, but rather it's our tension first because we happen to know the laws, or we happen to want to not get hurt. But and of course, one of the fundamental things in T-theory is the intention to survive. It would be a fundamental life force, the intention to survive. So the idea is that that intention would have initiated from this point in time, and that's why before we do anything, if we get formation to exist, physicality, it is first intended, and then we design the mechanism of how to put that into reality. So we collapse the waveform by our intention, and then our physical manifestation and capture of the energy and the formation. So I think, when I think, therefore I am, the thought became an idea, whether it was the idea of calculus, but that thought, because we have memory now, that thought became real and lived as a physical aspect of time. So a lot of the arguments, some of the arguments of mathematicians is that mathematics is real. And I would agree that mathematics is a form of reality. That form of reality is actually related to string theory in the sense that string theory proposes 10 space-time dimensions in which the energy embedded, so basically this singularity would have all these 10 or 11 space, would have the supersymmetry that's involved. So the singularity has the supersymmetry, and thus this, even though this supersymmetry has been broken, the closed loop strings represent the impression of that singularity upon the space-time membrane. The broken strings represent the physicality that would be involved that's on the space-time membrane. And the membrane is a membrane where all this can exist on, where all these forces and everything and gravity can pull energy, and where waves can exist. So energy becomes physical on the space-time membrane because it has broken symmetry. It also says that that again there's waves in the concept because quantum mechanics says fundamental reality is wave-like, and thus the question is whether those waves are being created and annihilated inside of this supersymmetric state, such that again when we have our intention, the energy is basically off the space-time membrane, so that we would actually have a sense in our body for the sense of intention. And like we have the sense of gravity, we would have also this sense of intention. And that means when we talk about senses, biological senses, and this will be another different part of T-theory where I talk about this, is how the relationship of energy to our senses, which I have not talked about, but put it this way. We have eyes because there's light out there. There's photons of light. So we developed eyes to that. If there weren't photons of light, we would not develop the sense receptor of an eye. So thus, if there's actually an intention energy, we would develop a sense receptor for intention. However, the sense receptor is not going to be a, quote, physical sense in the context of an eye, but it is in the mind's eye, because we have this mind's eye that sits inside of our brain, in which is, in T-theory, the mind's eye would be based upon really kind of a LIGO, which is kind of a gravity receptors, in which the concept in which you have multiple receptors out there inside of your mind that collectively work together to sense an energy. So the idea is, if you would, just like we have satellites are kind of an extension of our senses, we put a satellite there, we created, we intended, formed, and created a satellite which now senses an energy wave and then collapses that energy wave and sends it back to us. Likewise, our brain would be kind of like the satellite in the sense that it exists kind of in a physical structure of the neurons. However, the sense itself is actually due to a wave collapse or collapse of the wave function, in which we provide the intention to understand. In the process, that intention is connected to the singularity, and that's what's driving the collapse of the wave function. And that's why when we observe something, it would be based, and why we collapse the wave function in the dual slit experiment is based upon the intention to look. I don't know if they've ever done the actual experiment where they put a rat or a cat or a flea inside this box, and whether those species collapse the wave function. That would be the question. I don't know if that, but in the concept of in time theory is that we intentionally create the apparatus, we intentionally want to look for this information, so thus we're continually collapsing the wave function through our intention when we do that. So that's also explaining the possibility that intention is off the space-time membrane, and that when we, for example, if we observe, people say our dreams are not real. The individual dream is not real, but if we ask human beings whether they have dreams, well, then we must all have a dream receptor. In other words, a place where dreams and thoughts come together, collapse of the wave function, and that is universal among human beings. So the idea is that there's this sense for the mind's eye collapse of the wave function that may not be specifically linked to an area of the brain itself, but exists. And why we have a duality, or the mind-body problem, is that because it is due to this sense, which is sensing the intention of things prior to their physical existence. And that would, again, describe collapse of the wave function. Also, just to go into quantum entanglement, if we consider that the singularity exists as inside the Planck sphere, and an electron here would have the same distance to an electron across the universe, because it would access this singularity, and the singularity is in all space-time, just as the Higgs field is all in space-time. The Higgs field, actually, if it is all in space-time, it's partly due to this area range here, in which it's actually causing pull and formation of the particles, where they become heavier because there's an acceleration of energy causing the pull of things collectively together. Now, when we talk about, Einstein's idea, what a lot of people have taken is that space-time is actually causing the warpage of space-time is causing gravity, but that does not exist in the first singularity. They were talking a lot of times studying black holes, but the first singularity has no black hole with it. It has no event horizon. It is just a single point. So at this point, the singularity is prior to the breaking of symmetry, and the singularity exists in time prior to space-time. This describes a dualiverse, a physical model which is separated by the Planck time, or the Planck length, and the sphere, the Planck sphere, that is essentially at the center of all space. So it satisfies the concept, where's the center of the universe? The center of the universe is the center of all space, and that's why there's no center, because all space-time has the Planck sphere at the center of it, no matter where you go. So we're sort of kind of sitting on this membrane, in which is continually has energy driving, and all the collapse of the wave function, and all the forces are continually being formed at each moment. And so as we move through space-time, we're going, we pass through these Planck spheres, as a bed, but we're always having access to this energy continually. These are forces that are continually being supplied to us at each moment in time, which is now. So some people have mentioned that time is relative. Yes, time is relative to the individuals, but a lot of times that reference point is to observers and the speed of light. the question that T-theory says is that, what about how long does it take time to access the universe? And if this were singularity time we're talking about, it only takes Planck time to access the universe. So in relativeness to the singularity time, which is what they believe the universe started at, in reference to that time, then all things are of equal distance to the singularity. And that is the time reference point that T-theory brings forth, not observers in space-time. Newton made the mistake by calling it mathematical time. Mathematical time strictly deals with space-time, as mathematics breaks down inside Planck time and the Planck length. String theory predicts 10 to the 150 about universes, bubble universes. In T-theory, these would basically be all, 10 to the 150 would be all within the singularity in a single point, and not actually outside of our separate, separate universes. There would be, it's a dualiverse in which the 10 to the 150 universes, all the potentials for things that to exist here, and of course we broke symmetry of only 3 of these, which gave us our space-time. So in quantum mechanics and in string theory, the prediction of the 10 to the 150 universes is basically all tied up into one singularity in T-theory.